Next, we are going to see about the topic resistivity. See, resistivity is the intrinsic property of material in which how the material which oppose the flow of electron in the conductor. See, the resistivity which is also similar to the resistance, but the resistivity is different from resistance. So, how strong it opposes the current. Okay, so that is called resistivity. The resistivity is represented by the letter rho, and the resistance of the conductor depends on the length of the conductor and area of cross section of the conductor. The resistance is directly proportional to the length of the conductor and inversely proportional to the area of cross section. By combining both the quantity, then we will get R is proportional to L by A. And in order to remove the proportionality, R is equal to rho L by A. Here rho is called constant of proportionality. That rho is called resistivity of the conductor. It is also called as the specific resistance of the conductor. Suppose you just consider the length of the conductor is 1 meter and area of cross section is 1 meter square. Then substitute a quantity in that equation. You will get the resistance is equal to the resistivity. So that we can define what is resistivity. So resistivity of conductor is defined as the resistance of a conductor of unit length and unit area of cross section. See the resistivity. So from the equation what we have seen is R is equal to rho. At the condition when the length of the conductor is 1 meter and the area of cross section is 1 meter square. So that we can define the resistivity from that equation. The resistivity of conductor R is equal to, the resistivity of the conductor rho is equal to resistance of the conductor R when the length of the conductor is 1 meter and the area of cross section of the conductor is 1 meter square. So that is given in the definition. And the SI unit of resistivity is ohm meter. We know that the resistance, the SI unit of resistance is ohm, and the resistivity is a different property than the resistance. Okay, so resistance and the resistivity both which offer the opposition to the flow of current, but these two physical quantity differ with each other. Here the resistance can be changed with respect to the length and area of cross section, but the resistivity will not change with respect to length and area. Okay, the resistivity will change only the material is changed. For example, if you consider a copper conductor, if you are doubling the length of the copper conductor, the resistance of the copper conductor will change, but the resistivity will remain constant. Suppose in the second example, you just consider the copper conductor and you are changing the copper conductor into aluminum conductor. You just replacing the copper conductor into aluminum conductor. Now what happens to the resistance and resistivity? Both the resistance and resistivity will change. The resistance and the resistivity both are different from each other. Okay, see here the resistivity is specially, that is particularly constant for particular material. The resistivity will not change with respect to the length and area. So the resistivity for a common material is constant. For example, you are considering a copper. Whatever the changes made in the copper, you can increase the length, you can decrease the length, and you can increase the area of cross section or decrease the area of cross section. The resistance will change, but the resistivity will not change. So the resistivity will change only with respect to the material and the temperature. If you are increasing the temperature, the resistivity will change. But if you are changing the material, suppose you consider the copper, then the copper is replaced by aluminum, then also the resistivity will change. So the resistivity will change only with respect to two important factors. One is nature of the material, another one is the temperature. Other than that, the resistivity will not change with respect to length and area of cross section. we are going to see about the combination of resistors. So the resistor can be combined in two ways. One is the resistance can be connected in series. In another one, the resistors can be connected in parallel. So the first we are going to see about the resistors connected in series. Consider three resistors of resistance R1, R2 and R3 which are connected in series with battery and key. And the amount of current passing through each resistor is I. See, since it is connected in single path, it is not a multiple path. In a series circuit, all the resistor is connected in single path, so that the amount of current passing through each resistor will be same, that is I. And the voltage applied across these three resistors is taken as V, but the voltage across each resistor will be different, so that the voltage across the resistor R1 is taken as V1 and the voltage across the resistor R2 is V2 and R3 is V3. And next we are going to see what is the total resistance of resistors connected in series combination.
Is I amperes.
See, the total resistance of the combination of circuit is R ohm. And the total voltage V is equal to sum of voltages across individual resistance, that is V1 plus V2 plus V3. According to Ohm's law, V is equal to I into R. So, we can calculate the resistance R1 across which the voltage is V1 and the amount of current is I. So that we can write V1 is equal to I into R1. And next, similarly, across the resistance R2 and R3, the voltages V2 and V3, and write the expression for V2 is equal to IR2, V3 is equal to IR3, and substitute all these in the above equation, so that we get V is equal to IR, V1 is equal to IR1 plus V2 is IR2 plus V3 is IR3. So in this, I is common in both the side, so cancel that. So you will get R is equal to R1 plus R2 plus R3. So if the resistors are connected in series, then the total resistance of the circuit is the sum of resistance of the individual resistor. So the total resistance is R, and the SI unit of this resistance is ohm, that is equal to the resistance of resistor R1 plus R2 plus R3. So the total resistance R, it is also referred as the equivalent resistance or effective resistance. See, the total resistance is also called equivalent or effective resistance, which is equal to the sum of resistance of the individual resistor. Since the effective resistance of combination of series is sum of resistance of individual resistor, so that the resistance of series combination will always high than the resistance in parallel combination. That's what we are connecting the home appliances in the parallel circuit. See, in our home appliances, each appliances will have its different power. So according to that power, we should pass the current. If they are connected in series, the amount of current passing through all the appliances will be same, so which may damage the appliances. So that we are connecting the domestical circuit in parallel. See, from this, the total resistance is sum of individual resistance. So the resistance of the series circuit will be high, so that the current passing through the series circuit will be lesser. Resistors are connected in parallel. Consider three resistors of resistance R1, R2, R3 are connected in parallel with the battery and key. It is connected in the multipath. See, the resistors R1, R2, R3 are connected in the multipath, so that the current will be divided into 3, and the current passing through R1 is I1, R2 is I2 and R3 is I3, and the potential applied across the parallel combination of resistor will be same. Then if the current is divided into 3, I1, I2, I3, then the total amount of current I can be taken as I is equal to I1 plus I2 plus I3. So consider this equation 1. And according to Ohm's law, I is equal to V by R. So that I1 is equal to V by R1, I2 is V by R2 and I3 is V by R3. Then substitute these in the equation 1 and you consider Rp is the total resistance of the parallel combination. Then I is equal to V by Rp. That is the total current is equal to total voltage divided by total resistance. So substitute these in the above equation 1. Then you will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. From this, what we conclude is the reciprocal of total resistance in parallel combination is equal to the sum of reciprocal of individual resistance of resistors. Okay, see the total current. First we have to calculate the total current. I is equal to the sum of current passing through the individual resistors. So I1 plus I2 plus I3. Consider this is equation 1. Then according to Ohm's law, we know that V is equal to I by R. Then you change the expression for I. So that I is equal to V by R. Then we can write I1 is equal to V by R1, I2 is V by R2, I3 is V by R3. Since the voltage is constant, we are not taking the voltage as V1, V2, V3. So only we are taking I1, I2, I3 and R1, R2, R3. Voltage is constant throughout the circuit. And consider the Rp is the total resistance of parallel combination. Then the total current I in the circuit is equal to the total voltage V divided by the total resistance of parallel combination Rp. Then substitute the quantity in the above equation 1. You will get 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we can define the total resistance of resistors connected in parallel combination will be equal to the sum of the reciprocal of sum of reciprocal of resistance of individual resistor.